Alright, so in this video I just want to take a quick look at how sound is represented in computer systems. Okay, it's quite a tricky subject with lots of things to remember, so I thought a video might help you out a little bit. Alright, so the first thing to remember is the big problem we have, and that is that humans hear sound in analog and computers represent sound in digital. Alright, so remember, humans, analog, computers, digital. Alright, so that is the big problem we have. So anything that we hear in the real world, in analog, we need to translate into digital, and anything we create in digital, we need to translate to analog so humans can hear it. Okay, so if we have a sound in the real world that we want to represent on a computer, alright, we have to apply a system called analog to digital conversion. Alright, so we're starting off analog and we're going to turn it to digital. Okay, so you might see this represented as ADC, analog to digital conversion. Alright, now when we do this, we use a system called sampling. Alright, now sampling is where we simply take a sample of the analog sound wave and turn it into a digital signal. Okay, so before we do this, we just need to remind ourselves that sound waves have amplitude, and that represents how loud the sound is, and they have frequency, and that represents how high pitched or low pitched the sound is. Okay, so when we start to sample, we take samples of the sound and we translate those sounds to digital. Okay, now you can see here's an example of a digital sampling. Okay, you can see the sound samples themselves, represented as bars, aren't actually really hitting the black sound wave too much, and this would not produce that good of a sound. All right, it would be quite crackly and it wouldn't sound that much like the original. Okay, but if we take more samples per second, all right, we can do something like this, all right, and make every sample more narrow, which means there's more samples per second, which means that the sample rate is higher. But you can see that it will represent the sound wave a lot more closely, which means the sound will sound a lot more like the original. Okay, now you can see there's more samples there, so that means if there's more samples, the file size is bigger. Okay, so when we're talking about file size in sound, there are a few things that can edit or make the file size bigger. All right, number one, the sample rate, and that is what we were just looking at. Okay, when you've got smaller samples, it means there's more samples of them, which means that the file size is going to be bigger because you've got more samples. Okay, number two is the bit depth. Okay, now the bit depth is how many bits we give to each sample. Each sample, not all of them together, each sample. Okay, so if I give 8 bits per sample and I give 16 bits per sample, you can see obviously that the 16 bits is going to be bigger. All right, but what this does is it offers me more options or more range of representing the amplitude of the sound wave. All right, now because I've given more range to be able to offer for each sample that I make, it means that it means the sound is going to sound a lot better, especially if I'm playing it at a high level on a good sound system. All right, what you would normally find is that on the internet you're going to be dealing with sound that's probably about 8 bits per sample, and it's not going to be that good. All right, it's not going to be too good. But if you're dealing with a CD or on Spotify or something like that, it's going to be more likely 16 bits per sample, and it's going to be a lot better. Alright, but it's going to be bigger. Alright, which is why this is used for the internet, because it's smaller. Okay, because it's being sent all over the world, and you don't know how good the person receiving your file might have, what their connection might be. So if it's 8 bits, it's a lot smaller and it sends a lot better. Okay. Another thing that can change the size of a file is the channels. All right. Now if you think of channels, is the number of channels is the amount of different places the sound comes from. Okay. So if you're human, we have 2 ears, so we hear from 2 different places. All right. So we tend to, when we're using for stereos or personal devices like your phones, we tend to use 2 channels, okay, because it's going to be heard by 2 ears, your left and your right, or 2 speakers, your left and your right, okay. But that being said, there are a lot of surround sound systems that might have 6 or above. All right, they could be 6 or much higher. It's going to start at 6, but that is what gives you the effect of being able to hear things like that in real life. Like if a car passes on the TV screen, it sounds like a car's passing you on your surround sound system. All right, but again, it takes a lot more. All right, that's 6 outputs rather than 2, so it's going to be the file size is going to be bigger. All right, we can have 1 channel that is called mono. All right, but it's not that common, and it's normally, it was quite old-fashioned. I think that my parents would have probably listened to mono speakers when they were probably about your age. All right, it's not that common anymore. The most common one you're going to see is 2 channels, and that is stereo. All right, but when you go to the cinema or your home sound system, is going to have 6 or more, because that is surround sound. Okay. And the last thing that is going to affect the length or the size of the file is the length of the sound in seconds. All right, which is kind of obvious really when you think about it, because the longer the sound, the more memory it's going to take. Okay, so when it comes to working out file size, and I'm not going to do an example on this video because I'll make a video of an example when we actually do file sizes as a lesson, but to work it out, we need to know the bit rate. Okay, so the bit rate is equal to the sample rate. All right, that's how many samples are taken per second over here, multiplied by the bit depth. Remember, that's how many bits are given to each sample, which we talked about down here, multiplied by the channels, which is what we talked about here. Most of the time it's going to be 2, but it could be anything really. Okay, and that will give you your bit rate. Okay, now that would only give you half a mark, or half of the marks if you got a question in your exam for that, but for the actual full file size, we need to do a little bit more. We need to take the bit rate, so the file size is equal to the bit rate multiplied by the length in seconds. Okay, so if it's a minute, 1 minute, yeah, that's going to be 60 seconds. All right, if it's given in minutes, you have to convert it to seconds. Okay, and that is very, very basically how sound works inside a computer system, and I hope it makes it a little bit more clear after the lesson.